So pretty much today, what I'm going to do is I'm going to show you guys how to wire objects in 3ds Max. Pretty much wiring objects within 3ds Max is a pretty much useful technique to parameterize geometries for kind of responsive and complex, yet simple way to edit and manipulate geometries. It's kind of like using attractor points, which we'll be explaining later in my videos, where wiring objects can create interesting and informative outcomes, pretty much based on a real scenario or parameters that are defined by the user. Essentially, yeah, by allocating reference objects, we can pretty much assign different parameters to the geometry assigned. Which we're going to be using today is just a simple sphere, which it can be any geometry that we want. I'm going to use probably a pink, just because it's nicer. And the main components within this tutorial is within the helpers tab. Within the helpers tab, and what we can do is create a dummy. The dummy object is going to be our local reference, which will be scaling our geometry today, and a exposed transformer. The exposed transformer is a really helpful tool. It pretty much exposes an assigned object's parameters. Here on the right, so you get the Euler angles, you can get the distance, well positions. But what we have to do first is we will have to align it to our geometry. So just clicking align, and then what we want to do is mark the X, Y, and Z position into its center, and we want to apply that. And okay, so why we want to do this is because we want to place it within the center of the object, so then we can expose its parameters. So if we go to Modifiers tab, we expose the node, and then we click on our geometry. So therefore, our exposed node now exposes everything about our geometry, our sphere geometry, especially the distance to reference. At the moment, it's a reference to a parent object, which we will untick, and we will reference our dummy object to our local reference node. So we click that. So as you can see, now that we've done that, our distance to reference and all of our other things will have changed. Where if we move our dummy object and click on our thing, our distance to reference will change. This is important to note because the distance to reference is going to be our thing that we will be referring to and scaling our object, and which we'll be wiring our objects to. So what we're going to do now is we're going to wire the objects. So we click on our geometry, and then we go up to animation, and then we wire parameters. So we have two options here, which wire the parameters and wire the dialog, parameter wire dialog. We're going to wire the parameters, which we will then have a options menu. We go down to object sphere, and then we go to change radius, where we can within this tab we can change different aspects of the geometry. We can change the hemisphere, smoothness, segments, but today we're going to be looking at the radius. And once we click on the radius, we then have to choose what we're linking it to. So we then choose our exposed transformer, and then we want to transform our distance. If you remember, we were talking about earlier, the distance to reference. So we choose our distance, and then this is the wire parameter box. So this is where, I guess I'll explain this for a little bit. What it does is it indicates the control of direction. So if we scroll down on the right side, we have the distance exposed float control selected. So that distance will be controlling the radius of our geometry. So what will we do? And then in the bottom left here is our expression. So what we do is we firstly link this one-way connection, where we say the distance is then reliable for our radius, and then within the expression box corner, we will then set our expressions. So the expression pretty much says that the distance is equal to the radius of our circle, but we can alter this by saying the distance is divided by 2 to the radius of our circle, and therefore changes the thing, our geometry. So if we click connect, then we see that it changes its scale, its radius pretty much. And then this is interesting because it's now reciprocal to the distance of our dummy object. So this is a really smart and responsive way to kind of have our designs, and maybe we can use that to further our modeling techniques. But we can also change that. Maybe we don't want divide by 2. Maybe it's too small. We can times it, so asterisk by 2, and we can update that. So now, therefore, whatever the distance is between the exposed transformer and our reference, which is 107 at this moment in time, is times by 2 to get our current radius. And then if we move that, it gets bigger, it gets smaller, but if it gets smaller, our distance to reference changes. So we're going to go back. We're going to go back here. Cool. Back. Cool. What we're going to do now is I want to show you how we can apply this to a bit more coolness to it. I guess I'll show you if I Control V and I copy this. What we want to do, make sure when we do have multiple things that's referenced to one local reference, sorry, is that we always copy rather than instance or reference, because we want the exposed transformer to be exposed reciprocal to its geometry. So sphere 1 is located with exposed transformer 1, but the local reference node is with the dummy object. But with the one that's copied, the exposed node is assigned to the sphere 2, which is this one, but still locally referenced to the first dummy. So therefore, each distance to reference is going to be different. So therefore, each parameter or sizing of the radius will be different. So what we can do is we can, if we want multiple, we can array. Put 5 here, 5 there. We can preview. Cool. So we can create something like this. Default shading. We can create multiple boxes, kind of like a gloopy cube. And now we want to just try and wire all of these parameters. How do we do that? Okay. What we have to do, sorry, I should have explained before. We have to firstly wire the parameters of the object before we copy. So if we go wire over frame, so we select the object and then we wire the parameter, object sphere radius, link that to our exposed transformer, distance, connect that, and we say divided by 2, and we connect that. Cool. And we update. All right. So it's important to know within this process that always keep the original, I think, copy as a separate element, just because when we do the copy and we do the change, we copy the wired parameter over and over and over, which we then cannot change unless we go back, Control Z everything, and go back and change the original. So what we'll do here now is we will array all of this, and we click OK. So now all of these are wired independently, based on the original. So if I go default shading, as you can see, all of these gloopy little balls are scaling its radius based on its distance with the dummy object. What's interesting in this is that this can create a really responsive type way of modeling. So and a really fast iterative way. So if one day I liked this kind of geometry, but then I found out I needed to create others, I would then just create another dummy object. I would just move my dummy object and then create a new interesting form. What is also really important to note is that we cannot, unless we want to go through the pain of going through all of the parameter wire dialogues, all of the spheres, then we would have to go through all the spheres and then relink the radius to distance. But what we can do is we can just control Z, because this is the distance divided by 2 now. Maybe we want it to be a lot smaller. We control Z all of it. We go back to our wire parameters, transform the radius, transform the expression distance. And here we go back to our wire parameters. We change that expression to divided by, let's say, 5, which would be a lot smaller. So we update that, and then now we go back, and then we go Tools, Array, and we click OK. All right, cool. Now that we have that, and our expression is now distance divided by 5, the changing of the scales is a lot more, much more smaller. So what we can do is we can now see that it's all changed. Cool. I hope you really enjoyed this video. A bit chuggy, but pretty much we can change whatever geometry we want. We're not stuck to the radius of a sphere. Of course, changing the geometry will mean that there's more possible changes of our parameters. But just the interesting note is that the exposed transform is a really useful tool in identifying a reciprocal relationship between objects. Cool. Thanks, guys.